Hi. So, that's the question, how can we reduce the friction between two objects? So, the answer is, we can able to reduce the friction between two objects by reducing the contact area by using some kind of rollers, ball bearings or wheels. So by using these things we can able to reduce the contact area and we can reduce the friction between two objects. And also by changing the surface of the material we can able to reduce the friction between two objects. And also by creating a cushion of air, that is for example like a hovercraft or air hockey table, or one such example by creating a cushion of air and reducing the friction between two objects. Let us discuss about some principles of friction. The first and foremost thing is that friction acts parallel to the surface that are in contact. And also, the direction that friction acts is opposite to the direction of the motion. That is said to be intended motion. You can see here how the friction is acting upon an object. This one is the normal friction and this one is the applied friction and this one is the weight and this one is the friction in terms of K. One such example of friction is a roller coaster. You can see how the object is moving towards from the station and it is coming back again to reach the station. You can see how the friction force is acting over a knot. So this area is specifying the potential energy and this one seems to be the gravitation and this one is the free fall. This is the velocity of at what speed the object is moving. Here the object is nothing but the roller coaster. And this area is talking about the projectile motion, that is the centripetal acceleration. Over here you can find the friction and this seems to be the acceleration stress because you can see the bend and this one is nothing but the centrifugal force which is acting over on it. Since it is coming down and it's getting to be stable, so here you can able to see the kinetic energy. If we consider the types of friction, there are static friction and kinetic friction. Static friction is nothing but the frictional force that present just before motion begins. Whereas in terms of kinetic friction is the frictional force that present with motion. We have a note that is nothing but the static friction is usually higher than the kinetic friction. You can see some example over here of how the friction is acting upon. So you can find here. This is nothing but the force diagram in terms of side view and the blue color representation is emphasizing the normal move and the green is representing the weight and this seems to be the friction. We can able to calculate it by using the formation friction actual divided by the maximum range of friction. Now let's see about even more detailedly in terms of static and kinetic friction, a kind of rolling concept. As we knew, static friction is nothing but a friction which is at rest or is said to be moving. Kinetic friction are the moving one. So static friction is represented as Fs we have taken an object which is placed on some surface, you can see here. So this is nothing but a static friction. So you can see how the static equilibrium is acting upon it. Now, let's talk about the quantities in motion. Any motion that involves the three concepts. The three concepts are nothing but displacement, velocity and acceleration. These concepts can be used to study the objects which is in motion. You can see here the object which is in motion with continuous rotation over here. Now let us see about displacement. So what is displacement? Displacement is a change of position in time. In terms of displacement, F stands for final and I stands for initial. The formula specification is over here. Del x equal to xf into tf minus xi into ti. Displacement is considered to be a vector quantity. So this is the graphical representation of a sample displacement. So this one is the initial one and this one is the final one. It has been calculated over here with del r value. Now there are other more points in terms of displacement. Displacement has both magnitude and direction. That is in terms of plus or minus sign is the indication. And it has a unit in terms of length that is mentioned in meters. You can see here the positive direction and the negative direction and how it is acting upon. So from the origin point we can find positive direction over this side and negative direction over this side. So as the statement proclaims, displacement is having both magnitude and direction in terms of positive direction and negative direction. Let us talk about velocity. So velocity is nothing but the rate of change of position. Velocity is a vector quantity. Velocity has both magnitude and direction. Velocity has a unit of length divided by time, that is meter per second. You can see a car moving towards the direction towards this side is having a specification of time in hours and the distance in miles. So the rate of change of position is nothing but the velocity. You can able to see over here. In terms of velocity, there are actually three quantities which will be concerned. The first one is average velocity, the second one is average speed, and the third one is instantaneous velocity. If you see over here, there are some few formula specification, that is velocity AVG is nothing but average. So average velocity equal to del x divided by del t, that is nothing but xf minus xi. F is the final one and I is the initial one, and this is nothing but the time taken, del t. So if you calculate this one, we can able to find the displacement. And this one seems to be the average speed, that is represented as SAVG. So the average speed will be calculated with the formula as total distance divided by del t. So here total distance is the distance, and if you see upon this instantaneous velocity, the formula specification is V equal to limits del t to 0. The limits is from del t to 0, and the formula del x divided by del t, that is equal to dx divided by dt. Here del x is the displacement. So these are the three quantities of velocity, and these are the related formulas. Now let's see about average acceleration. Changing velocity, that is non-uniform thing. So the changing velocity means an acceleration is present in it. So acceleration is the rate of change of velocity. And acceleration is considered to be a vector quantity. And acceleration has both magnitude and direction. Average acceleration has a dimension of length divided by time to the power of square, that is m divided by s square. Average acceleration can be calculated by a formula AAVG equal to del V divided by del T, that is equal to Vf minus Vi divided by Tf minus Ti. F stands for final and Ti stands for initial. And instantaneous acceleration will be calculated as A equal to limits del T tends to 0. So del V divided by del T equal to dV by dt, that is equals to d divided by dt into dx divided by dt. So we'll be getting a value of answer as d square v divided by dt square. Hope you understood and learned the concepts. Thank you. From GTech.